Okay, in this fourth video, entitled Fractional Distillation of Ideal Mixtures of Liquids, we pretty much summarize what we just discussed in looking at Rayote's law. And so basically this document explains how fractional distillation works, and we will try to identify in our own lab, where these various things are happening as we go through the fractional distillation column. And so when we look at the phase diagram, recall that we generated the phase diagram where we were able to plot on the x-axis the mole fraction associated with the two different components, A and B. We see over here on the left we have all B, and B, as we said, was the more volatile of the components because it has the lower boiling point, which would be the higher vapor pressure. Over here, fully over on the right, we have A, all of A, and we know that A is the less volatile component, again because it has a high boiling point or a low vapor pressure. And so if we take a look then at what's happening, we had said before that the blue line corresponded to the composition of the liquid, the solution of the binary solution. And we said that the pink corresponded to the composition of the vapor sitting above the surface of the liquid. And so if one was to start with a high concentration of the less volatile component and a small concentration of the more volatile component, and this would be very appropriate for our situation where we have water and we have about maybe 8 or 10% ethanol, which is the higher volatile component. And so we may start the process at this particular concentration, C1. What this blue line says that the boiling starts whenever we reach a certain point, and in this particular case it would be close to the boiling point of the pure component, the water. But then as that boiling occurs in the vapor just above the surface of the boiling liquid, we have a vapor at that particular temperature that consists of a larger amount of A and a less amount of, a larger amount of B, but a less amount of A. Again, because B was the more volatile component. And so what has now happened is our vapor has gotten richer in the B. And then if there is a place within the system that vapor can feel a lower temperature, it can then condense. And so it would then go back into the liquid. And that liquid then would have a boiling point that corresponded to this point here. Now, where is that liquid? Well, in our column, the liquid can't be the original liquid, but what happens is as the vapor condenses up in the column, it lands on a marble that is at a little bit lower temperature so that it condenses, and so we have a liquid that is wetting that particular marble. Now, if that marble has reached the temperature given by this here, then what's going to happen is the liquid that's on that marble will boil, and what will happen is the vapor that is around that particular surface will have an even higher composition of the volatile component. And then again, if that vapor can find, as it travels up the column, it might find a marble that is a little bit cooler, and it may condense at that point. And then at that particular point, it will boil, and then what happens is the vapor coming off at this particular point, which was C3, then will actually reach a composition that's almost all the most volatile component. And so the fractional distillation column basically has this process occurring, where once we finally get the vapor at this high value of ethanol, it then can possibly leave the system, hit a cooling coil, and actually condense out outside of the system. And so we've extracted a percentage of the ethanol from the original mixture. And now the original mixture would probably be starting, is as we take more and more of the ethanol out, it would be at a different composition, and basically it continues as we go along. And so by using the phase diagram and reading the discussion here, you can see what is happening during that process. Now again, how does it work? In the lab, you have the mixture that was originally boiled, and then you have these packed beads, and what happens is the temperature is decreasing as it goes up, and so these beads form surfaces at lower and lower temperature for condensation to occur and additional boiling to occur. Eventually what happens is a vapor that has a high concentration of the more volatile component then finally makes its way up to this point, and then as it travels down here, there's water, a cooling water jacket, and that can then cause condensation to occur, and then the products are collected at this particular point. And so there's some notes as to this would be a piece of laboratory equipment you might find in a chemistry lab or something to that effect. And so you can see some of the notes associated with that. And again, what's actually happening as we discussed before, we see that the vapor over the top of the boiling liquid will be richer and richer in the more volatile component, and it will eventually reach a certain point. And again, I'll let you go ahead and read through here as it discusses the various compositions and what happens to the vapor, and how one can get the liquid to a point where the vapor above that liquid has a higher and higher concentration. In a industry, a similar thing is happening where you have these various trays and you have some overflows and other things like that. And so you have the hot vapor coming up. And again, I'll let you go ahead and read what's happening here. But you have that area for the vapor to recondense. And when it recondenses, it's at a higher fraction of the volatile component. It boils, and that then comes to the next level, and it recondenses again at a higher fraction and just continues the process. So with that, I'm going to go ahead. That is the section on fractional distillation.